my dear students, welcome back to Dr. Maran's Chemistry Academy. So we're going to continue with question number 8 for SEM 2 STPM Chemistry. So the question is two steps mechanisms for the reaction between ozone and nitrogen dioxide are given below. As you can see, there are two steps of equation. Nitrogen dioxide reacts with oxygen, will give you nitrogen trioxide and oxygen, and the second equation is nitrogen trioxide with nitrogen dioxide to give you dinitrogen pentoxide, right? So we have to split of the equation. Ideally we need to understand, the question already stated that the first equation is a slow step and the second equation is a fast step. So from here we can derive that the slow step is a rate determining step, right? The fast step will not be a rate determining step. So whenever we want to write the rate equation with the rate constant, it must be the first step, which is a slow step, because this is a rate determining step. So what we're going to do next is we're going to see in this equation what would be the intermediate species. Meaning to say, the intermediate species will be formed as a product and will be used in the second step as a reactant. And usually what we will do is we will combine the one particular equation. The actual equation will be, we know that NO3 is formed as a product and NO3 is being used up here. So this NO3 will be cancelled off and we can merge or combine this equation. Hence we can see that NO2 and NO2 is on the reactant side. So ideally if we were to write the whole equation, it will be 2NO2 reacts with 1 mole of oxygen to form N2O5 and oxygen. Alright, so this is the ideal equation that we can see, right? This is the ideal equation that we can see. Now this is the splitting of the equation. So we're going to use each equation to answer this question. At 60 degrees Celsius, the initial concentration of ozone and nitrogen dioxide are 0.03 mole per dm cube and 0.05 mole per dm cube respectively. The rate constant for the reaction is 0.037 dm cube per mole per second. Which statement is true about the reaction? So let's look at option A. The rate of reaction increases 4 times when the concentration of ozone and nitrogen dioxide are doubled. So if you look at my previous lesson, what we're going to do is we have to write the rate equation. So the rate equation will be, since I have no space, I will try to maximize the space whichever I can. So it is rate constant, and make sure that we choose the slow step because this is a rate determining step. Hence, the concentration of nitrogen dioxide multiplied by the concentration of oxygen. So this will be the rate equation, right? And we know that maybe we can calculate the rate for the entire equation since we already have all the information here. So rate constant is 0.037 dm cube per mole per second, right? And then multiply by concentration of nitrogen dioxide, which is 0.05 mole per dm cube, and then again multiply by the concentration of ozone, which is 0.03 mole per dm cube. Alright, so what we're going to do is we're going to find the answer. Okay, we try to sort this out first. So we get 5.55 Now what is the unit? Of course unit we need to cancel out. Alright, unit we need to cancel out. So the answer is 5.55 times 10 to the power of minus 5. So the unit we can cancel off. dm cube can cancel off with dm cube. Mole and mole. And yeah, that's all. So the final unit will be mole per dm cube per second. So this is the rate for the entire equation, right? 5.55 times 10 to the power of minus 5 mole per dm cube per second. So now if you look at the first option, the rate of reaction increases 4 times or factor 4 when the concentration of ozone and nitrogen dioxide is double, right? So what we can see with respect to nitrogen dioxide and with respect to oxygen, what we can see here is this is the first order reaction, right? This is the first order reaction, and since it's the first order reaction, when the concentration is double, the rate of reaction also double. But here is because the overall order of reaction is 2. Always remember, if let's say the concept for the order of reaction is 2, when the concentration is double, the rate of reaction is increased by factor 4. That means it is quadruple. Okay, it is increased by 4 times. So option A is correct. Alright. Now let's look at option B. The rate of reaction increases when the concentration of nitrogen trioxide increases. Okay, please be very careful that nitrogen trioxide here is an intermediate species. Okay, when we talk about intermediate species, it is being cancelled out and it is not exist as the final product or exist as the reactant. Alright, it is being cancelled out because I already showed you. Can you see this is the final complete equation. We don't see nitrogen trioxide, so it has no effect on the rate of reaction. So option B is out. Option C, the rate of reaction is second order towards nitrogen dioxide. I already mentioned is a first order. Overall rate order is second order. But with respect to nitrogen dioxide, it is the first order. Hence, we can't choose option C. C is out. For now, we accept A. A is the correct answer. But let's look at D also. The rate of reaction is 9.25 times 10 to the power of minus 5 mole per dm cube per second. So our actual answer that we initially calculated was 5.55 times 10 to the power of minus 5. So obviously the answer is wrong for option D. Hence option D is out. So we left with option A. So option A is the correct answer. Alright, so I hope you have actually tackled this question in a very meticulous way. Okay, so I will see you in the next session for the next question discussion. Alright, thank you so much. Follow for more updates for Dr. Maran's Chemistry Academy. I'll see you in the next session.